question is like this. We have to evaluate the value of integration of this function 5x minus 2 upon 1 plus 2x plus 3x square with respect to x. Now to solve this question, we see that this function which we have to integrate is in the form of linear upon quadratic expression of x, right? This 5x minus 2 is a linear expression and 1 plus 2x plus 3x square is a quadratic expression. So these types of questions are solved by some special method, and the method which we are going to use is like this, that we are going to write the numerator 5x minus 2 as equal to lambda times d upon dx of 1 plus 2x plus 3x square plus mu. On differentiating 1 plus 2x plus 3x square, we get 5x minus 2 as equal to differentiation of 2x is 2, 1 is 0. So we are not going to consider the differentiation of this as equal to 0. And 3x square is on differentiation gives me 6x. So I get this as 5x minus 2 is equal to lambda times 2 plus 6x plus mu. I mark this as equation number 1. Okay. Next, I am going to separate the constant terms and the variable terms in the left hand side to obtain the expression 5x minus 2 is equal to 2 lambda plus mu, which are my constant terms, plus 6 lambda x, which are my variable terms. Okay. On comparing the coefficient of x, we see that on left hand side the coefficient of x is 5, and on the right hand side we have the coefficient of x is 6 lambda. Okay, so we get 5 is equal to 6 lambda, or lambda is equal to 5 upon 6. We can mark this as equation number 2. Similarly, the constant term on the left hand side is minus 2, and on the right hand side the constant term is equal to 2 lambda plus mu. So we get minus 2 is equal to 2 lambda plus mu, which is our equation 3. Now we are going to substitute the value of lambda in equation 3 to get minus 2 is equal to 2 into 5 upon 6 plus mu. This 2 can cancel with 6 to get 5 upon 3. So we get minus 2 is equal to 5 upon 3 plus mu. This 5 upon 3 can be written on the left hand side as minus 2 minus 5 by 3 as equal to mu, or we obtain mu is equal to minus 11 upon 3. So after calculating the value of lambda and mu, we have to substitute these values in equation number 1. Okay, so on substituting, we get 5x minus 2 is equal to 5 upon 6 times the d upon dx of the denominator plus minus 11 upon 3, right? So taking the value of 5x minus 2, we are going to substitute in the integral to obtain the expression like this, and dividing separately the denominator, I am going to get these two integrals which I can mark as I1 and I2. Okay, so the idea here, by assuming the integral as I1 and I2, is that we are going to solve them separately, right? I1 is equal to 5 upon 6 times 2 plus 6x upon 1 plus 2x plus 3x square. So 1 plus 2x plus 3x square on differentiating give me 2 plus 6x. Therefore, I am going to substitute 1 plus 2 plus 3x square is equal to t. On differentiating both sides, I am going to get 2 plus 6x dx as equal to dt. Right? So this will be equal to 5 upon 6 times integration of 1 by t dt. Okay, now integration of 1 upon t is equal to log t, so this is going to give me 5 by 6 log of t. Substituting the value of t as equal to 1 plus 2x plus 3x square, I'm going to get this as 5 upon 6 times log of 1 plus 2x plus 3x square. Okay, now I'm going to solve I2. Now taking I2, I see here that the integral is in the form of a constant upon a quadratic expression. So such types of integrals are solved by writing the quadratic term in the denominator as difference or the sum, whichever is possible, of the square of a variable term and the square of a constant term. Let us see how we are going to do it. So taking the denominator, and since the coefficient of x square is 3, so we are going to take 3 as common. Taking 3 common, I'm going to get this as 3 times x squared plus 2 by 3x plus 1 by 3. Now the coefficient of x is 2 by 3, half would be 1 by 3. I'm going to add and subtract 1 by 3 whole square to this expression. So I'm going to get x squared plus 2 by 3x plus 1 by 3 whole square minus 1 by 3 whole square plus 1 by 3. The first three terms are x plus 1 by 3 whole square, and these two constant terms can be simplified. So I'm going to write this as 3 times x plus 1 by 3 whole square minus 1 by 9 plus 1 by 3. This on simplification gives me 3 times x plus 1 by 3 whole square plus 2 by 9, which gives me x plus 1 by 3 whole square plus root 2 upon 3 whole square. Now I'm going to substitute this value for the denominator to obtain I2 as equal to minus 11 upon 3 whole upon this expression. Okay, now this 3 and this 3 are going to multiply to give me minus 11 upon 9 into integration of 1 upon x plus 1 by 3 whole square plus root 2 upon 3 whole square with respect to x. Now to solve this integral, I am going to substitute x plus 1 by 3 as equal to t. Differentiating both sides with respect to x, I am going to get dx is equal to dt. So this will be equal to minus 11 upon 9, 1 upon t square plus root 2 upon 3 whole square. Right? Now I know that integration of x square plus a square with respect to x, sorry for this dt, is equal to 1 upon a tan inverse of x upon a. So this will be equal to minus 11 upon 9, 1 upon root 2 upon 3 tan inverse of t upon root 2 upon 3. So this will be equal to 11 upon 3 root 2 tan inverse of 3t upon 2. On substituting t as equal to x plus 1 by 3, I'm going to get this as minus 11 upon 3 root 2 tan inverse of 3x plus 1 upon root 2. Here you can see on taking LCM, I'm going to get 3x plus 1 upon 3, and this 3 cancels out. Okay, so we have solved I1 and I2, and therefore the value of the given integral, which was equal to these two terms, which we have assumed as equal to I1 plus I2, is equal to 5 upon 6 times log of 1 plus 2x plus 3x square minus 11 upon 3 root 2 tan inverse of 3x plus 1 upon root 2 plus c. So this is my required answer. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.